Hello everyone, in the last lecture we talked about matrix operations and we defined matrix multiplication and did an example on it. So in this lecture we will do more examples on matrix multiplication. Let me start by a simple example. So I will start with 2 by 2 matrix. So it's a square matrix. For example, if we have a square matrix A equals 1, 2, 3, 4, and 2 by 2 other matrix B equals, for example, 1, 0, 3, 2. So in this example we have 2 by 2 matrix, and the other matrix is also 2 by 2. So to do the multiplication, we can do, in this case we can do AB and we can do also BA. They may be not the same because the matrix multiplication AB and BA not always the same. Some cases it can be, but we can say that they are the same before we compute them and see if they are the same. Let's start by AB. For example, we have AB equals the matrix 1, 2, 3, 4 times the matrix 1, 3, 0, 3, 2. So the result will be equals, it will be 2 by 2 matrix also, because here when we multiply this one will go with this one and we will get the number of rows here and the number of columns here. So it will be 2 by 2. So the first position here, it will be this row with this column. So this row here with this column here. So it will be 1 times 1, which is 1. 2 times 3, which is 6, or plus 6, which is 7. So we'll get here 7. And this entry here at this position is this row with this column. So it will be 1 times 0 is 0, and 2 times 2 it is 4. So it is 4. And the entry here at this position is this row times this column. So it is 3 times 1, which is 3, plus 4 times 3, which is 7, or 4 times 3, which is 12. So it's 3 plus 12, which is 15. So here it will be 15. And this entry at this position is this row times this column. So it is 3 times 0 plus 4 times 2, which is 8. So it is 8. To compute BA, we will write here the matrix B, which is 1, 0, 3, 2, times the matrix A, which is 1, 2, 3, 4, which is equals, here 1 times 1 is, here to get this entry here, we will multiply this row with this column. So it will be 1 times 1, which is 1, 0 times 3, which is 1. So 0 times 3 is 0, 1 times 1 is 1. It is clear that the matrices are not the same, because once they have the same size 2 by 2, but as this entry not equal to this entry, so that means these two matrices are not equal. And to get this position here, to get this entry at this position, we multiply this row with this column. So it is 1 times 2 is 2, 0 times 0, 4 is 0, so 1 times 2 is 2. And this, to get this position, we multiply this row with this column. So 3 times 1 is 3, 2 times 3 is 6, so 3 plus 6, it is 9. And to get this entry at this position, we have 3 times 2, which is 6, plus 2 times 4, which is 8, so it is 14. Now let's see another example. Here we have 3 by 3 matrix and also 3 by 3 matrix. So these two matrices are square. So when we call this A and this one B, so the multiplication AB will be equals this matrix here, 2 minus 1, 2 minus 1, 3, 4, 2, 1, and minus 6, minus 1, 2, times this matrix 3, 1, minus 4, 2, 5, 6, 1, 4, 8. So the result matrix will be here 3 by 3, so the matrix will be 3 by 3 matrix, so it will like that. Sorry. So at this position it will be the first row times the first column, so it will be 2 times 3, which is 6, minus 1 times 2, which is minus 2, and 3 times 1, which is 3, plus 3, so this is 7. I will get here 7, and at this position we'll have this row times this column, so it is 2 times 1, which is 2, minus 1 times 5, which is minus 5, and 3 times 4, which is 12, which is 12. So we'll get 2 minus 5 is minus 3, plus 12 is 9. And at this position is the first row here, and this the last column here, so it is 2 minus 4, which is minus 8, 1 minus 6, which is minus 6, and 3 times 8, which is 3 times 8 is 24, so it is 24. So this is equals minus 8 is minus 14 plus, so it is 10. So here we get 10. Now we get the first row, so the first row here, and we want to get the second row here. So to get the second row, we have this second row here times these 3 columns. So to get the position is 4 times 3, which is 12, 2 times 2, which is 4, 1 times 1, which is 1, so this is 17. Isn't 5, 17, yes. And this row with this column, it is 4 times 1 is 4, 2 times 5 is 10, 1 times 4 is 4, so this is 18. And to get the answer at this position, we'll multiply this row with this column, so it is 4 times 4 is minus 16, we have minus 16, 4 times minus 4, and 2 times 6 is 12, so plus 12, and 1 times 8, which is 8, which is equals, here minus 16 plus 12 is minus 4 plus 8 is 4, so this is 4. And for the third row here, we have at this position this row times, or this row here times this column, so it is minus 6 times 3, which is minus 18, minus 1 times 2, which is minus 2, and 2 times 1, which is 2, so plus 2, which is, so this go with this, and we get minus 18. So here we have minus 18. And at this position here, we have this row times this column, so it is minus 6, minus 5, 2 times 4 is plus 8, so this is minus 6 minus 5 is minus 11, plus 8, which is minus 3, so this is minus 3. And this row times this column gets minus plus 24, minus 1 times 6 minus 6, 2 times 8 is 16, plus 16, so this 6 goes, this 6 will have 10 plus 6, 34, so here we have 34. So let me write it here and erase this to compute the BA matrix. So I will erase this and write the matrix here. So the matrix AB is equals matrix 7, 9, 10, 17, 18, 4, minus 18, and minus 3 and 34. This is the matrix AB. Now I will compute the matrix BA, and I need to read this part to compute it here. So the matrix BA will be a 3 by 3 matrix, because you have here 3 by 3 and 3 by 3. So this 3, which is the first, which is the row of this matrix, and this 3, which is the column of this matrix, will be our size for the next matrix. So BA will be the matrix 3, 1, minus 4, 2, 5, 6, 1, 4, 8. And the matrix A is 2, minus 1, 3, 4, 2, 1, minus 6, minus 1, 2. This is equals matrix. Here for this entry here is this row times this column, so it is 3 times 2, which is 6. 1 times 4 is 4. Minus 4 times minus 6 is 24. So this is 10, so it is 34. So this, we can say directly that the two matrices are different. So AB here is different from BA, because this entry is different from this, and we don't need to look to the other entries, because once one of them is different from the other, that means the matrices are different. And this entry here is this row times this column, so it is 3 minus 1, so it is minus 3. 1 times 2, which is 2. Minus 4 times minus 1, which is 4. So this is equals 3. So here is 3. And this row times this column, so it is 3 times 3 is 9. 1 times 1, which is 1. Minus 4 times 2 is minus 8. So this is equals here 10 minus 8, which is 2. So 2. And for this row we will have 2 times 2, which is 4. 5 times 4, which is 20. And 6 minus 6 is minus 36. This is equals, so this is equals minus 12. So it is minus 12. The entry here at this position is this row times this column, so it is minus 2. 5 times 2 is 10. 6 minus 1, which is minus 6. So this is minus 8 plus 10, which is 2. This is here is 2. And this position here is this row times this column, so it is 2 times 3, which is 6. 5 times 1 plus 5, that is 6. And 6 times 2, which is 12. So this here is 18 plus 5, which is 23. This is here 23. And the entry here is the third row times this first column, so it is 1 times 2, which is 2, and 4 times 4, which is 16, and 8 times minus 6, which is minus 48. So this is equals, minus 30. And the entry here at this position is this row times this column, so it is minus 1. 4 times 2 is plus 8. 8 times minus 1, which is minus 8. This 8 going on, we will get minus 1. And this entry here is this row times this column, so it is 1 times 3, it is 3. 4 times 1 is 4. And 8 times 2, which is 16. So here plus 16. So this is equals, here is 4 plus 16 is 23. So this is equals also 23. It is clear that the matrix AB and BA are different, even if they have the same size. Each one is 3 by 3, 3 by 3, matrix. Now we will look to another matrix with different size. For example, this matrix here is square matrix 4 by 4, and this one matrix here is 2 by 4. So when we call this matrix, for example, A, and this one is B, so the products AB, which A here has 4 by 4 and B here is 2 by 4, so is impossible, is indefined, because this 4 here is different from these 2 here. But the product BA is defined, because here we will have 2 by 4 and here 4 by 4, so this here is equal to this here, so we can get BA, but we can't get AB. We'll now compute the products BA. So BA equals the matrix B, which is 0, 5, 2, 2, 1, 3, 0, 4, and the matrix A, which is 4 by 4 matrix, so it will be 2, 3, 6, 5, and 3, 3, 7, 9, and 6, 7, 1, 3, and 5, so here, 9, 3, 0. So this matrix will be equals. The result matrix will be a matrix with 2 rows and 4 columns. So we'll have matrix with 2 rows and 4 columns. So it can be the form. To get this entry here, we will multiply this row by this column. So it will be 0 times 2, which is 0, 4 times 3, which is 15, 2 times 6, which is 12, and 2 times 5, which is 10. So this is equals, here is 27 plus 10 is 37. So it is 37. And this entry at its position is this row times this column. So it is 0 times is 0, times 3 is 0, 5 times 3 is 15, and 2 times 7 is 14, and 2 times 9 it is 18. So this is 47, I think it's 47. And to get this entry here, we multiply this row by this column, so it is 0 times 6 is 0, 5 times 7 is 35, 2 times 1 is 2, 2 times 3 is 6, so this is equals, so this is equals 43, so it is 43 here. And this entry here at its position is this row times this column, so it is 0 times 5 is 0, 5 times 9 which is 45, 5, and 2 times 3 is 6, so it is plus 6, and 2 times 0 is 0, so it is equals 51. And to get the second row here, we will multiply by this second row with these columns. So for the first entry, we have here 1 times 2, which is 2, 3 times 3 is 9, 0 times 6 is 0, plus 4 times 5, which is 20, so it is 20. So this is here is 29 plus 2 is 31, so this is 31. And to get this entry here, we will multiply this row with this column, so it is 1 times 3 is 3, 3 times 3 is 9, 0 times 7 is 0, and 4 times 9 is equals 36, which is equals 48, which is here 48. And this entry here is this row times this column, so it is, let me count it here, 6, 3 times 7 is 21, and 0 times 1 is 0, 4 times 3 12, so this is equals, which is equals 39. It's really 39. So this row times this column is 1 times 5 is 5, 3 times 9, which is 27, and 0 times 3 is 0, 4 times 0 is 0, so this is equals 32. So this is the matrix BA, which is 2 by 4 matrix. That is from this 2 by 4 matrix multiplied by this 4 by 4 matrix.